Hi dear students, welcome to Brilliant Online Classes. In this session, we are going to study two important naming reaction for your competitive examination, NEET and JEE. The reaction is nothing but aldol condensation and cross-aldol condensation. Okay. So let's study first of all their detailed mechanism, how the product is forming, and then we can go for the short trick. Okay. So we have the aldol condensation. So what is mean by aldol condensation? That first of all we have to know. See, aldol means it contains one aldehyde and alcoholic group, right? Aldol. Condensation means what? Just elimination of water, like dehydration. And in aldol condensation, all the aldehydes and ketones cannot undergo aldol condensation. Some particular conditions are required. What are the conditions? Mainly two conditions are required. First one, the reacting aldehydes and ketone must contain at least one alpha hydrogen. What is alpha hydrogen? You know, the main functional group directly attached to carbon is said to be alpha carbon. The alpha carbon contain hydrogen is said to be alpha hydrogen. Am I right? So, alpha hydrogen containing aldehydes and ketones can react. And the second condition, the reaction must be carried out in presence of a dilute alkali. For example, dilute NaOH. So the two conditions, the reacting aldehydes or ketone must contain at least one alpha hydrogen. Second condition, reaction takes place in presence of a dilute alkali. First, I am discussing about the detailed mechanism for the reaction aldol condensation. Let me take one of the example. CH3CHO. You know what is this compound CH3CHO? Ethanol, right? Ethanol. Two carbon containing aldehyde, ethanol. Is it contain alpha carbon? Yes. You know this CHO is the main functional group. Nearby carbon is said to be what? Alpha carbon. And the alpha carbon contain hydrogen is said to be alpha hydrogen. So here we have three alpha hydrogen, right? And this one. Let me just write one of the alpha hydrogen like this. For example, CH2H. Okay. Just one of the alpha hydrogen. And I'm writing like this. And it is reacting with what? Dilute NaOH, right? Dilute NaOH. You know the NaOH species which contain Na plus and what? OH minus, right? What will happen? You know OH minus is the basic part. This hydrogen is acidic part. Why it is acidic? Why this hydrogen become acidic? Because this is a, CHO, aldehyde is a electron withdrawing group. Electron withdrawing group will increase the acidity, right? So this hydrogen is acidic in nature. So this OH minus, let me take the OH minus. This OH minus, it can abstract this acidic hydrogen. And what happened? This bond shifted towards this carbon. So what this carbon charge become? Negative. So the reaction becomes CH2 minus and here we have CHO. This is the compound we are getting. We are getting a nucleophile part. See what is a nucleophile? It's an electron rich compound, right? Negatively charged position is there. So it is a nucleophile. And aldol condensation mean it is the reaction between two same aldehyde. It can be ketone condensation. Then it will be reaction, two ketones are reacting together. So this is one of the aldehyde. Let me react with another same aldehyde. What is that? CH3CHO, right? Ethanol. Let me write the product. What will happen? This nucleophile will attack into this carbonyl carbon and this changes to O minus. So let me write the reaction from this side, okay, with this CH3. So we have CH3, this CH3, it is connected with one carbon and this O becomes O minus. This carbon carries one hydrogen, okay, and to this carbon which will attack this CH2 and here we have CHO. This is the product forming, right? In this compound, we are considering dilute NaOH. Okay, in this reaction we are using dilute NaOH. So dilute means what happened? Water will be there. And this water molecule, what is water? Water which contain H plus and OH minus ion. And this hydrogen is attacked by this OHO minus group. So what happened? This H plus, if it is attacked here, this compound becomes OH. So the product will be CH3, CHOH, CH2, C double bond OH. This is the compound we are getting. This is the final product is called what? Aldol. Why the name aldol? Because it contains one aldehyde and alcoholic group. See all of you. This is CHO, aldehyde group, and this is OH, alcohol group. Therefore, it is known as aldol. Aldol. And or we can say that aldol is also known as beta hydroxy aldehyde. Beta hydroxy aldehyde. Why it is beta hydroxy aldehyde? See, this is as per the priority order of the functional group, aldehyde and alcohol when you consider, which is the major functional group? Absolutely aldehyde. So this is the major group. So main functional group nearby carbon is called alpha carbon. Nearby carbon is called beta, gamma, etc. So here beta position contain one hydroxy group. Therefore it is known as beta hydroxy aldehyde. Okay. So beta hydroxy aldehyde is short form, is called it as what? Aldol. Aldol. Process is not completed. What is our reaction? Aldol condensation. So water has to eliminate. Okay, water has to eliminate. Let me take this compound once more. What is our compound? CH3, CH, OH, CH2, CHO. This is our compound. Okay, aldol. When this compound heated, it will eliminate water. Dehydration can be happen. From where the water molecule can be eliminated. Very simple. OH we can take from this carbon, OH. Nearby carbon we can take one hydrogen. OH I am taking from this carbon. From the nearby, either this or this, you can take one hydrogen. Which will prefer? I am going to prefer this hydrogen, the right one. Because if you eliminate this OH and this hydrogen, if you eliminate water, your double bond is forming in between this alpha and beta carbon. Right? This is the most substituted alkene. According to Zaitsev rule, we know that the more substituted alkenes are more stable. Right? You can make the OH and hydrogen from this side. So the double bond will be this. But it is a less substituted alkene. Make the double bond in a more crowded area. That is called Zaitsev rule. According to Zaitsev rule, the more substituted alkenes are more stable. Okay, more stable. So I am removing this OH and this hydrogen. So our final product will be CH3, CH double bond, CH single bond, CHO. What is this compound? This compound is called aldol, right? Aldol, because it contains one aldehyde and alcoholic group. And this one is known as ene, right? It's contain a alkene and aldehyde. Therefore, it is known as what? Enol. It's contain a alkene and aldehyde. Therefore, it is called what? Enol compound. Okay, this is called what? Aldol condensation. So, when an aldehyde, you can carry out the same process with a ketone also. But the ketone must contain at least one alpha hydrogen. For example, propanol. Propanol, we can use it. The same mechanism you can follow. So this is the actual mechanism for the aldol condensation. But for NEET and JEE competitive examination, we don't have enough time to write the all mechanism and finding the answer. We need a short trick. How to find a given aldehyde, how you can convert into aldol, and how you can convert into final product on heating, enol. That we are going to study about the short trick. Let me consider the same aldehyde. What is the aldehyde? CH3, CHO. CH3, CHO. Okay, ethanol. Let me react with one more ethanol. Aldol condensation means it is the reaction between two same species. First, what we are doing? First, you are treated with dilute A alkali NaOH. Okay, fine. How to write the aldol product directly. Okay student, let's study a simple idea. This is your first compound and this is your second compound. From your second compound, take one of the alpha hydrogen. Okay, from your second compound, take one alpha hydrogen and you just add that hydrogen into this oxygen. Okay, from the second compound, take one of the alpha. You know, this is the alpha carbon because this is the main functional group. Nearby carbon is called alpha carbon. Alpha carbon contain hydrogen is said to be alpha hydrogen. There are 3 alpha hydrogen actually. Just take one alpha. Let me take one alpha hydrogen and just attacking to this oxygen and it become OH. Double bond will become single bond. So it becomes COH. That's all. So what happened here? I'm starting from this side. We have CH3. Then what you have here? CH. I told you this double bond O becomes OH. And after that, you know, this is the carbonyl carbon, right? So to this oxygen, you added one hydrogen and it become OH. Double bond becomes single bond. Okay, fine. After that, this carbon means the oxygen containing carbon must be connected with which carbon? The alpha carbon atom. That's all. Okay, this CO carbon, this C must be connected with which carbon? The alpha carbon atom. Finish. So what you can write? CH, then it is connected here alpha carbon. What is that? Already one hydrogen you removed, remaining CH2 and then you have CHO. See, this is our product, right? This is our aldol. See, this is the main functional group aldehyde. This is alpha, this is beta, and beta hydroxyaldehyde is called it as what? Aldol. Aldol. Now you can write your dehydrated product. On condensation, on heating, what will happen? This OH and this hydrogen eliminated as water. And you will get the product CH3, CH double bond, CH single bond, CHO. This is our enol. Okay, this is the easy method how to write the aldol product. Now you have a confusion like how you can do with a ketone. Let's try. Let me take one of the ketone, nothing but acetone. You know, CH3, CO, CH3. It's acetone, right? CH3, CO, CH3. Right? And after this one, let me take one more acetone or propanone. CH3, CO, CH3. What we are doing first? First we are treated with dilute NaOH. Dilute NaOH. Same procedure you can carry out. What you have to do here? From the second compound, take one of the alpha hydrogen. You know, this is the ketone is the functional group here. So the nearby carbon, both are alpha carbon. You can take any one of them. Okay. So let me consider this is your alpha carbon. I'm taking one of the alpha hydrogen from the CH3. And where you want to add that? Yes, you have to add on this oxygen and it make it OH. It becomes COH. Double bond becomes single bond. Okay. It becomes COH. And after that, very careful, this carbon, okay, this carbon must be connected with the alpha carbon. This carbon must be connected with which one? Alpha carbon. So let's start the product. I'm starting from this side, okay. CH3, we have CH3, this CH3, and here what you have C, on this carbon, this O becomes OH. And this C which contain one methyl group, let me write it just below. Why? Because this carbon should be connected with this one. So this C gives single bond. Where it is connecting? Here. Already we took one of the hydrogen and placed here. And what is left here? CH2. So it becomes CH2 and it is connected with what? COCH3. See, what is the main functional group here? One ketone is there, one alcohol is there. As per the organic chemistry, their priority order, ketone is the main functional group. So the CO, nearby carbon is called alpha, nearby carbon is called beta. Here beta contain one hydroxy group that is called beta hydroxy ketone because its beta position contain alcohol on a ketone. So beta hydroxy ketone, or it is known as what? ketol, right? Ketol, because it contains a ketone and alcoholic group. So aldehydes when react, when two same aldehydes then react, you will get aldol. When two same ketones will react, you will get ketol. Okay, and ketol also can undergo dehydration, condensation. When it eliminate water on heating, it will eliminate water from where? The OH and one hydrogen. According to XII rule, more substituted alkene is more stable. So your final product will be CH3, CH3, double bond CH, CO, CH3. Right? This compound which contain one ketone and an alkene. We studied a compound which contain one aldehyde and one alkene is known as enol. So a compound which contain ketone and alkene is called it as what? Enol, right? Enol. This is the final product. Now let's study one more technique, how to identify the final product. Now we saw that when two aldehydes are reacting, and first we will get aldol, then on heating it's giving enol, right? Now I am going to teach about that, how these aldehydes can be directly converted to the final product, means enol. Final product we can get it. Student, let me take the first example, CH3CHO. That was our first example. We reacted CH3CHO with the same CH3CHO. Right? Here, how to write the final product, enol, directly? Very simple. The first compound, let me write in this pattern, like CH3COH, okay? CH3CHO. Just write the oxygen in the linear pattern. After that, take the second compound. In the second compound, you know, this is the functional group and this is the alpha carbon. Alpha carbon contains 3 hydrogen, right? Let me just write the alpha 3 hydrogen, 2 hydrogen like this. CH2, okay, and one more hydrogen is there along with CHO, okay. So the first compound you make the oxygen in the linear pattern, and the second compound you take the 2 alpha hydrogen like this. Why we draw like that? In order to eliminate water. See, you can eliminate this water molecule and what you will get, this is the final stage, okay, means first you are treating with what? Dilute NaOH. Second, you are treating, means heating the compound. So after this compound, directly write the product. What you have on the left side? CH3, and here what you have? CH, and double bond is there. Okay, double bond, and where it is connecting? This CH, and it is connected with a CHO. See, this is the main functional group. This is an alkene, right? This is called as what? Enol. This is the final product. Suppose if you need aldol, what you have to do? Just, you know, what is aldol? Beta hydroxyaldehyde. Which is the beta position? This is main functional group, alpha, beta. On beta position, you put a OH. Here you put a H2, means double bond, you have to remove it. It becomes aldol. That's all. Similarly, let's treat. What is the second example we consider? That is acetone or propanol, right? Acetone or propanol. What is acetone? CH3COCH3. It's reacting with CH3COCH3. Let's do the same mechanism. Let's find the final product. Okay. So in this one, what you have to do? CH3CO. Okay, I told you, O oxygen, you make it in the linear one, and CH3. And from this compound, what you have to do? Take one of the alpha. You know, this is alpha carbon. This is also alpha carbon. You can take any one of them. From one alpha carbon, make the 2 hydrogen like this. Okay, like this. And what is left? CH and then CO, CH3. Okay, fine. First, I am treating with dilute NaOH. Second, I am heating the compound. What will happen? You can eliminate this water molecule and all together you combine. What we can write? Here we have CH3. Here we have C, on which there is a CH3. Double bond, where it is connecting, this double bond is connecting here, the CH, and then you have COCH3. COCH3. What is this compound? It's contain a ketone and an alkene. It's known as what? enone, the final product. Suppose if you need the middle one, means the ketone, what you have to do? Make a OH on this. This is the main functional group. This is alpha and this is beta. On this beta, you make a OH group, cut the double bond, one more hydrogen here. Okay. So these are the simple idea to write the product of aldol condensation for your competitive examination. Now let's check it about what about cross aldol condensation. Okay. See student, cross aldol condensation means nothing but it is a reaction between two different aldehydes or two different ketones or one aldehyde, one another ketone. Aldol condensation and ketone condensation, we discussed that it is a reaction between two same aldehyde together, also two same ketone together. It's not like that. Cross aldol condensation mean it is a reaction between one aldehyde, for example, ethanol with a propanol, propanone with a butanone, and propanone with a propanol, like that. Let's check it. The same mechanism, you can in simple way, you can write the final product. For example, the first reactant is CH3CHO, ethanol. Let me react with a propanone, CH3CO, CH3, propanone. What are the compounds, student? The first one is ethanol and the second one is propanone, ethanol and propanone. These are the two compounds we are reacting. In a cross aldol condensation, total we will get 4 products. Okay, during a cross aldol condensation, if the two reactants contain alpha hydrogen, total it will give you 4 products. Let us check it. What are the 4 combinations? See, the first combination is one ethanol can react with one another ethanol. This is one product. And the second one is one ethanol can react with one propanone, the second one. And what about the third one? The third one is one propanone can react with one ethanol. One propanone can react with one ethanol. So you may think ethanol react with the propanone and propanone react with ethanol, both are same. No, these are different. See, what about the fourth combination? The fourth combination will be propanone with one another propanone. Okay, propanone react with one another propanone. So these are the 4 combinations. Let's check it. What are the products of the 4 combination? Let me write ethanol. How you want to write ethanol? CH3CHO. Okay, this is ethanol. What about the other ethanol? Write the 2 alpha hydrogen like this and you carry out ethanol. This is the one. If it undergo reaction, how can you write the product, student? Just we discussed this elimination of water and how you write? Here CH3, CH, the CH, double bond, here CH, CHO. This is one of the product. Let us check it the second one, ethanol. What is ethanol? That is CH3, CHO plus propanone. Write 2 alpha hydrogen on propanone like this and you have COCH3. Okay. And how to write the product? Eliminate water, just combine. You will get CH3, CH, double bond, CH, single bond, CO, CH3. The same way you can find the other one, third combination, propanone. Propanone is CH3, CO, CH3 and ethanol. Ethanol, 2 alpha hydrogen, CHO. And on combination, elimination of water, you will get CH3, CH3, double bond, CH, single bond, CHO. And let's go for the last one. Propanone react with another propanone. What is propanone? CH3, CO, CH3 reacting with one another CH2 and C double bond O, CH3. And final product will be water is eliminating CH3, CCH3, double bond, CH, CO, CH3. Can you tell me, student, in all these 4 products, any one of the product is repeating? No. Let us check it. What is the name of the first product? What is the compound name? You know, aldehyde is the main group. Therefore, 1, 2, 3, 4. How to name this compound? This name is bute. Parent chain is bute. Second position there is an alkene. First position there is an aldehyde. Therefore, bute-2-enol. Bute-2-enol. What about the second one? You know, ketone is the main functional group, so it should get the lowest number. So 1, 2, 3, 4, 5. They contain 5 carbon atom. Therefore, its name will be pend. Okay, pend. Third position there is a alkene. Second position there is a ketone. Therefore, pend 3N2-on. Okay, that's a name. And what about the third compound? You know, the main functional group is aldehyde. Therefore, 1, 2, 3, 4. And third position there is a methyl. Therefore, 3-methyl. Total 4 carbon. Therefore, bute. Second position there is a alkene. First position there is an aldehyde. Therefore, bute-2-enol. Okay, bute-2-enol. What about the last product? Here, ketone is the main group. So 1, 2, 3, 4, 5. Fourth position there is a methyl. So the name can be written as 4-methyl. Total 5 carbon. Therefore, pend. Right? Pend. And third position alkene. Therefore, 3N. And second position there is a ketone. Therefore, 2-on. This is the product. See, any one of the product is repeating. 1, 2, 3, 4. All are different products. So while you are using during a aldol condensation reaction, this is the reaction between two same species, so you will get a single product. But during cross aldol condensation, these kind of 4 products can be formed. So through this simple idea, you can write the final product. Suppose if you ask the middle one, which one? Whether they are asking aldol or ketol, what you have to write, student? From the final one, how this enol is forming? You remove one hide OH group from this CH, right? You know, this is the functional group. This is alpha carbon. This is beta carbon. From beta carbon, there will be a OH, and here it will be one more hydrogen, and double bond becomes single bond. From that compound, you are eliminating water, and you are getting the final product, enol. So that you can get it back, the aldol and ketol from the final product also. So these are the simple way of answering which one, aldol condensation and cross aldol condensation, for your competitive examination. Within second, you can find the answer for the cross aldol and aldol condensation. So I hope you get the clear idea about the aldol condensation and cross aldol condensation. Very important reaction for your competitive exam. So hope you get the idea. We will meet again with some other tricks and tips in the upcoming classes. Thank you all.